It's one of the biggest F1 regulation changes ever. The new for 2026 F1 regs could very well turn the sport on its head. This is Nailing the Apex. I'm Tim Hauraney. Here with me to discuss it all and other things from the race, it's Ed Straw and VIAPlay, Nelson Valkenburg. Guys, great to see you. Ed, you guys have been really busy over at the race, but were you able to find some space for a bit of downtime for yourself?
Yeah, probably about a week or so, but now back and raring to go. Rule changes are always exciting. So we're in that phase of the season before the fatigue sets in and everybody starts to struggle. So maximum attack at the moment.
Nelson, I hear you've had some snow in the Netherlands. What gives? What's up with that?
Well, I can't really cry about snow against the Canadians, so I'll refrain from any further comment, except for the fact that the Dutch are hopeless with 3 bits of snow, and then it's done.
All right, so we're here to talk about the 2026 regulations. F1 released some finer details about the regs, engine, car design, which you can watch right here. If you want to click here, you can rewatch the podcast we had done on that, a bit of an explainer. But I wanted to dive in a little bit more on the details because I can see this as being very complex and complicated. So I think it's just good if a lot of us get out in front of it. Let's start with the new for 2026 V6 turbo hybrid. There'll be a split power 50-50, 50% of the power coming from the internal combustion engine, and you've got 50% coming from the battery. The max electric power, I believe, if I remember this correctly, is about 350 kilowatts. And then the max internal combustion engine power will be 540 brake horsepower. So you've got about 1,000 horsepower to play with. However, some of these things may change with how teams have been able to develop their power units, and it's something we'll touch on a little bit later. But for now, Ed, I'll start with you. You know, when you first saw just how much of a power increase the OEMs were supposed to get from the then current battery to this 2026 battery, I mean, what did you think?
Yeah, it was always ambitious, and this was foundational to the rules. And really, pretty much everything has followed that insofar as they've got this 50-50 electrical to conventional, if you like, V6 power. And actually, in reality, it's going to be a bit close to 55-45 probably, and it will gradually shift around. So that was the foundational thing. And it was always going to be the challenge of how you come up with all the other rules around that to work. And they have had to do a lot, because so much of what we see on the chassis side is all about finding ways to create a car that actually allows you to get around a track quickly over a race stint, given the limitations you've got on harvesting energy, et cetera, et cetera. So it was always a big challenge. They've committed to it fully. Maybe you could argue they've overcommitted on that in terms of the knock-on effects. But I think probably what we've seen, even though the exact details of the journey and how those rules have been built up and refined weren't clear, the big picture that it was going to be all about making that split and the amount you needed to do in terms of the hybrid power compared to where it is now was going to dictate almost everything. And it's going to be the same once we're on track, because that's going to be absolutely critical how well you manage the energy and harvest the energy in terms of how competitive you are.
Yeah, Nelson, it's sort of a similar type of a question for yourself. I mean, when you first saw these, regulations or the idea of the way that the FIA and F1 were going in when it came to these power units, I mean, what did you think?
From a political standpoint, quite logical, because when these were dreamt up, these regulations, they were in a world when OEMs were told you cannot build and sell combustion engines past 2030, 2035. The world has slightly changed, and maybe in hindsight, F1 and the FIA would have done things differently, but this is where they are, and they've given the teams a massive opportunity to make a difference. The OEMs will have the opportunity to make a difference now, and that's going to be very fun.
Also, Nelson, I mean, it's a massive increase in energy from the battery. And it has me questioning, just how much the teams may struggle to recapture that energy and how much they will have to play with inside of a race. So when things are sort of fully charged, these cars are going to have to try and find ways of regenning that energy quite quickly, aren't they?
Yes, because a lap time isn't just one straight or one sector, but that is the challenge, and there is some fear that will be difficult in the beginning. But I think we might be seeing this year the steepest learning curve we've ever seen in F1. People will learn about this technology, will develop this technology, will make it raceable so quickly that the pecking order after 2 races might not be the pecking order after 6 races or 8 races. It will come thick and fast. The developments on software and raceability, and it is a massive challenge, and it will be interesting in the beginning to see who gets it right from the get-go and who gets it right a little later, but maybe finds the golden egg in drivability. But it is an engineering nerd's fantasy, this regulation set, or nightmare.
Mm-hmm. Yeah, and Ed, you had mentioned it was probably going to be more 55% internal combustion engine, 45% battery. But at the time, they were looking at it being 50-50. Just explain a little bit more, what some of the challenges are going to be when it comes to these batteries, and maybe not harvesting, but trying to recapture a lot of that energy and get it back into the battery to be used again and again.
Well, fundamentally, not all circuits are equal when it comes to how much you can harvest. So that's the big challenge. You'll have some circuits that it's much more comfortable, and some where you are really, really, really struggling. And what we know is, even on the most favorable circuit, if you were trying to use the maximum possible power all the time, your battery would run out very, very quickly. So you'd be constantly going down to no electrical energy deployable. So you've got to manage that quite heavily. So it then comes down to, how do you best utilize the electrical energy you've got for the best lap time? And that's a slightly different challenge on a qualifying lap compared to in steady state running for a race stint. So that's the big challenge. And that's why you've heard drivers talking about, going to have to lift off and shift down at the end of straights in order to not spend too much of that and then get into your harvesting phase. And there's going to be little bits and pieces as well. There'll be driving techniques that depend on that can harvest you that little bit more. Small differences, but for example, you'd see that sometimes with Alpine last year when they were struggling in terms of ERS harvesting. Slightly more aggressive downshift strategies and things like that can be used. So there's lots of little details you can do there. So it becomes a numbers game at heart, in terms of there's a certain amount of energy available to you in terms of the fuel going in and what you can harvest. And you've got to spend that in the best possible way, hopefully with a power unit package that utilizes everything as efficiently as possible, to get from start to finish in a race as quickly as possible, while also racing other people. And within that, using some of the tools you've got to maybe spend a little bit more or save a bit more in that battle. So it's quite a cerebral challenge that is going to dominate the early stages. It'll probably be the biggest part of the competitive equation early on. But I suspect as time goes on and you see more convergence from the power unit manufacturers and all of the strategies and everything converge, then its share of it will reduce a little bit. This isn't going to be 5 years of whoever's got the best power unit is winning every single race, even though it's possible it could start that way.
And I also don't think that that what the drivers have been saying during 2025 will long be the reality for within this development curve, because it's going to go so quickly. F1 is so best placed to make the most out of this regulation set compared to any other form of motorsport, that I think the reality of day one will really not be the reality of day 30 even of the season.
And the reality of day one as well is going to be different to the reality in the sim that some of the drivers were talking about in the second half of last year, because things moved very, very, very quickly. So be careful about some of the more extreme negative. I mean, there are things in these regs to criticize, absolutely, but it's not going to be the worst case scenario that's been talked about, because it never is. But F1 loves talking about that when rules are changing.
I'm so glad you said that, Ed, because this is the discussion I've had with Tim for 5 months now, and now I have an ally. Yeah, this is good. We're on the right track here.
Well, the thing is that, like, dude, we see how much management had gone on when the V6 turbo hybrid was introduced, right? And then, there still is or was that management, going on. And now when we come into this regulation, I only see more managing, like even more so, because of now relying so much more on the battery and trying to get through overtake mode and boost mode, things that we'll touch on in a minute. But that's how I kind of see this. I do see there being even more management, not only with the tires, but now also more so with the power units.
Yep, and this is every day our world gets more complicated because of technology, and F1 is no different. It will never be a fully atmospheric V10 and go right at it again, unless they create the best synthetic fuel ever and they have the political wind in their sails. But otherwise, it'll be like this.
I think it's worth noting, though, that for all of the talk about efficiency and saving, you still have to drive the car quickly. Just because you're not going at the theoretical 100% at a given time of the car doesn't mean you're not driving it at 100%. And in fact, there'll be, as we'll probably talk about later, ways and means for drivers to stand out under that. So I think it's important for people to think of it not as a pure exercising kind of sitting back and sauntering your way to the checkered flag, because it's absolutely not going to be that.
Which leads us to these different modes that the drivers are going to have to play with. I mean, overtake mode instead of DRS. We now that's going to allow hopefully for some more overtakes. But in essence, when a car is like a second or more closer to the car in front, they will have access to overtake mode, producing that full 350 kilowatts from the battery, which is going to allow them to pull off a move on their rival. But there will be those specified detection zones like with DRS, right? I mean, we're replacing something with something else, and you're also adding on top of that a boost mode. And Nelson, you do the broadcast for these things in Dutch. I mean, how are you going to navigate all that?
Well, impossible for you guys to follow, at least, so I'm safe on that score. But it is going to be a challenge for us broadcasters to make sure that the race is clear and logical, and that what is happening on track also translates to your commentary. And we're in talks with FOM about graphics with this, because graphics will save us or kill us in our broadcast. But in essence, you're right. Drivers will have a full attack mode to use, but that will always come at a price. You can't do this lap after lap after lap. Things will overheat. Your energy consumption will be too high. Your tires get worn too quickly. So it's not like a free-for-all, just like DRS wasn't a free-for-all. Because in the beginning in the age of DRS, people thought, well, it's all going to be so easy to overtake. And for a while, it was a little bit easier. And look at what kind of season we had last year. DRS did almost nothing at the end of the year. So that will also vary from track to track, and drivers who are defending will have the opportunity to use extra boost to defend as well from time to time. So you'll have to be super strategic with how you do this, and also super clever. And I'm so interested to see which drivers come to the fore in that.
And it's going to be really hard to monitor from the outside, because even if you have state of charge graphics and that kind of thing, the state of charge of the battery is going to vary so wildly. It's not going to be like Formula E, where you start at 100% and it kind of broadly counts down, because it's going to be changing so much, because you can't put that much into the battery. That's the problem. You can't store that much. So you're going to be constantly adjusting the state of charge. People have seen the battery levels sometimes turn up under the old regs, and it moves around a reasonable amount, but it's not anything like as dynamic as we're going to be seeing, because you are more reliant on that battery power. You are using a lot more of it to get around the laps. So even if you were, Nelson, to be sat there with live feeds of the state of charge of everything, it's going to be changing so quickly that actually there's going to be very little you could make of it in the moment. So it's really, really complex from that perspective.
It will be complex, and you can almost compare this to Group C racing in the 80s, when we were on a maximum allowed fuel capacity, and some people would use their fuel allowance in the beginning of the race to pull away, and others at the end. And and that wasn't opaque. That wasn't clear what would happen at the end of the race. So for us to learn to read these regulations and read the race with everything that will be going on, that's going to be the fun challenge and very interesting.
Well, when you've got an overtake, I mean, let's say I'm average fan. I don't watch F1 all the time, but when I tune in every once in a while, I'm going to be seeing cars out on the track, and all of a sudden you're going to hear the announcer talk about overtake mode and then boost mode, and what is the difference?
Overtake is what it says on the tin. It's an overtake. It is the attacking party. Boost mode is either you're going to go for fastest lap or you're defending. But I think we have to simplify it. The average fan wants to see cars overtaking cars in great racing. And if this gives us more overtakes, I think we just have to make sure that us who want every bit of information, we have to find the middle road for the average fan and the long-term fan. But we're all going to be on a journey with this with this form of racing together. I did a lot of Formula E commentary, and I went on a journey, and I learned with Formula E, if you enjoyed the show, then I come from Formula Ford, the most basic form of motorsport, maybe the most pure. My Formula Ford heart bled when I did Formula E commentary, but the viewers liked it. So I think we're just going to have an open mind and make sure that we cater to all of our fan bases, or F1's fan bases in this case, and make sure that wherever we can explain stuff, we explain stuff. But the show needs to be good enough for us to not have to rely on explaining every little thing.
Why not just go with something simple like push to pass? Like I know it's already being run in IndyCar, and I get you don't want to do the exact same thing as IndyCar. I get that, but why not just have something as simple? I mean, you can call it whatever you want, but one straightforward mode that's going to allow you to do both of these things. Instead of having overtake and then boost, why not just try and find a way of combining the two of them? Like, are these just two different engine modes they're working with, Ed? Like, how is it going to work?
Well, the difference ultimately is the way when you're allowed to use them primarily. They're not exactly the same modes as well, but the overtake mode is basically DRS. It's just the mechanism for the DRS effect. It's not aero. It's based on power. So you could actually argue they could have just kept DRS as a phrase and said, this is no longer drag reduction system. This is something else. Come up with a name that aligns with DRS, because actually to the fan watching it, the effect is the same. It's, are you a second behind? You get to the activation zone, you deploy it, you've got an advantage. So that's the same thing. So maybe they could even have used that, because I think that's kind of what most people think of when DRS is talked about. They're not necessarily automatically thinking about, first and foremost, the rear wing opening. So that's the thing. You've got two slightly different things there, and at least calling that one overtake, it lines up, because that's the car that's doing the overtaking that can do it. And the boost mode is a bit more like what they've had with the old engines, where you could, at the push of a button, just get a bit of extra power that you can use at your discretion, should we say. But when you're doing that, you're still governed by different rules to it. So it is complicated, but it's still going to be cars sat running together. And the actual, when you're on the normal boost button, doesn't matter so much. But I think if you called them both the same thing, which I do appreciate the simplicity of, it doesn't quite work, because they're different things. Because if me and Nelson happen to be racing our cars down the straight and I get on the boost button, Nelson can as well. But if I'm on the overtake button, because I'm within the 1 second, Nelson can't do that, if you see what I mean. And he's restricted by other things. So it's complicated, but there's just slightly different effects. And people will get used to it, I think, in the end. It's just a little bit of a shame that you still have to have what is effectively DRS, which was originally introduced as a temporary solution, had it for 15 years, and now we've got a DRS in effect, just by a different means to make it possible to overtake. So
for recharging these batteries, and Ed, I'll come to you first, Ed, and then Nelson, I'll get your opinion on it. But these batteries they're going to be they're going to need to be fed. And that's being done with kinetic energy now, because the MGUH is gone, and the MGUK is going to be the one doing a lot of the capturing of the energy. I mean, to help replenish the battery. Can you just talk about this a bit more, Ed? Because it's like where and on what components is the battery going to be recapturing this energy from? Like, how is the car going to be used to basically fill the battery back up?
Well, basically, the MGUK, just think of it as two-way. It can deploy or it can take, but it can't obviously do both at the same time. So there's a point where once you are not doing maximum deployment from your MGUK, and you can go into basically think of it as negative power almost. That's when you start charging, and it goes from something that's putting power out into something that's taking power in. So basically, any time you're not using that, you can harvest, and that's not purely limited to when you're on the brakes necessarily. And obviously, it's just all about making sure you've got the maximum efficiency of that to get as much of that energy back into your battery as you possibly can. So that's where it all happens. And obviously, we've got there's talk about different rear brake specs that people are talking about, because the MGUK is a braking mechanism when it's doing that. So do you actually want to have slightly smaller rear brakes because you want to lean more on the MGUK? And then how big an effect does that have dynamically in terms of your braking and the balance under braking and all those things? There's loads and loads of complexities into it. It's never in Formula One a two-dimensional thing. So you look at that energy equation and you work out the best thing to do, and you think, okay, how's this going to affect things dynamically? And that's when it gets really complicated and interesting. What's the optimum approach you can take? So it's quite hard to get your head around, because we're kind of used to engines, certainly in terms of cars. You kind of think energy in, power out, isn't it? You fill it up with your fuel, press the loud pedal, and you go, and you're consuming. But it's a much more two-way thing, and it can have a big dynamic impact. And you see that, for example, in Formula E, where right from the start they had the regen paddle, and that was a braking mechanism. And drivers, when they first jumped in the car, would be surprised by just how much of a braking effect that had. So yeah, that makes the MGUK something that's almost a little bit taken for granted, but that's absolutely critical to this, because that is your mechanism, not only for going as quick as you can, but being able to go as quick as you can a little bit further around the lap, because you've taken the energy in as well.
I'm also thinking that you're also going to be doing a lot of, or using the engine. So engine braking, I'm assuming. Engine braking, you're going to be able to capture energy from that. Lift and coast, I guess you would also be able to capture some energy from that. But is there anything else? Like I remember speaking with, which driver was I talking to about it? I think it might have been Lance, but revving the engine sort of in the corner, essentially.
Which is sort of the blown diffuser style of driving, where you kept the revs up to create downforce. Here, you'll keep the revs up potentially to get a trickle effect into the battery, and it will be very interesting to see who adapts the quickest to a new driving style, and who works the best with his performance engineer and his systems engineer to figure it out from track to track to track, because that's maybe the most interesting part. A Ferrari system might be way better on Monza type tracks, for instance, than they are in the really twisty parts. And who gets it right may not be dominating the most races, but maybe they're second, third the most times. It's very interesting.
So there's two reported teams in Mercedes and Red Bull powertrains, Red Bull Racing's engine department, essentially, that could start the season, Ed, with a bit of an advantage. You guys over at the race did a great job of reporting on all this. As I guess you're going to be way more qualified to speak about the technical aspects of all of this, but somehow they've achieved a higher compression ratio. And I know that's a bit confusing for the average fan to kind of come in and try to understand how these two teams have gotten this tiny bit of an advantage, but it is an advantage. And how much of an advantage do you think it could be for these two teams to start the season with?
Well, some of the ones who aren't doing it are talking about 3-4 tenths a lap, which might be overstating it, but The thing is, it becomes difficult because all of these regs, you have your limits for what you can do with your engine architecture, etc. But the laws of physics are not very well behaved when it comes to keeping everything steady state. So as soon as things get hot, they change, and there's different thermal characteristics, and there's various different things you can do. So as soon as you have a rule where you measure the compression ratio cold, and that's a simple measurement, then that means when it's hot, if you can get enough of a change of state in some way, shape or form, some mechanism that's legal, then you'll make a gain. And you have to remember that with these engines, cylinders, they're sort of short and squat. They're not tall beer cans. They're the sort of short, stubby ones. So actually, a very short difference in stroke can actually make a big difference in terms of allowable stroke, and because that changes your compression ratio. So 16:1 is the limit. It's suggested that what particularly Mercedes might be doing, and maybe to a lesser extent Red Bull, but again, don't know exactly what they're doing. So this is all to an extent hearsay or what you've been told, could get you up to something approaching 18:1 again. So that would be a big advantage. But we know that the other power unit manufacturers aren't doing whatever they're doing because they've been complaining about it and lobbying the FIA, but we don't know what they have been doing. So I wouldn't assume that automatically means Mercedes and Red Bull powertrains are going to be ahead. They might be ahead on that element, but there's other elements as well. So this is what it's all about. And people will say, well, you should have a rule because it does say it's got to comply at all times. So if you want to have a maximum compression ratio of 16:1, you can say it can never run above that. But that's really, really hard to test. So it's not like
then we need to invent new technology.
Exactly. So there are different ways of getting around things, because if they were to say come up with a mechanism in the thing that when you measure it, you're not measuring what it really is, and there's something they can secretly push a button that no one notices, and it changes the dimensions, that would be illegal because that's a deliberate misleading of the measuring process. But if you measure it accurately and fairly cold, and it's 16:1, and it's a simple measurement, like I say, but it changes once you're up and running, and it's not by some illegal mechanism, then it's fine, because that's what everybody's going to be trying to do with every single aspect of the power unit if they can. It's just Red Bull and Mercedes have obviously worked out a way to do it, and they're going to hold a meeting about talking about what they do with this. But these things aren't simple and easy changes. They couldn't just snap their fingers and say, no, don't do that. That's likely to be for next year. So it's a bit of arguing to go on there. And there could be other things. Who knows? Because while the other manufacturers are going to be sort of sneakily behind closed doors complaining about it, they're certainly not going to be talking about whatever clever thing they're sitting in their factories, rubbing their hands, thinking, oh, no one else has done this. This is going to be great. So this is all going on in the background.
Nelson, I mean, how do you think the FIA is going to police all this? I mean, there's a lot here.
Well, let's talk about flexi wings. And this is the engine version of a flexi wing. Under static load, they all complied. And then on onboards, we saw them moving. That is the problem that the FAA as a policing force in this faces. Because you have the FAA on one hand writing the rules, and then you have 11 entities trying to find ways to bend them. Let's say not break, but bend the rules. And they're the more clever people, the more money, the impetus to try and beat the rules in effect is there. So it is difficult for the FAA in any championship with any set of regulations. If there's so much money, so many good people involved to make sure that you can actually police it, it's very difficult. So that I wouldn't want to be let's say Joe Bauer and the people at the FIA right now, because they created this regulation set, but there are a lot of avenues that the teams can get very creative. And that is not cheating. That is what F1 is. Get creative with the regulation set you've got.
Yeah, play within the gray area, essentially, and find ways of playing well in that gray area. You had said flexi wings, Nelson. That moves us on to movable aero. I mean, aerodynamics that are going to be moving. So, like we saw with DRS, where the rear wing opened when a car was within a second of their competitors. Now, both front and rear wing elements will move. Ed, can you just describe how all of that will work and why the FIA decided to go in that direction?
Yeah, it's a fairly straightforward thing. I mean, the reason is because they needed to reduce the drag on the straights while still having enough downforce to go quickly around corners, basically. So that's what you need to achieve a decent F1 kind of lap time. And they're talking about the cars being maybe 1 second, 2 seconds slower, depending on the track than they were at the back end of last year. So it's actually really straightforward. There's not that much clever you can do with it, because any car when they're in the corner are going to be in corner mode, and any car when they're on the straight are going to be on straight mode, which basically means it's leaned out. You've knocked some of the downforce off, you've knocked a load of the drag off, and it's a bit like a DRS front and rear. There's no restrictions on when you can do it, other than there will be prescribed zones, because basically it's going to be used when you're not traction limited, as it were. So once you're on a straight and you're not at risk from wheel spin from still having lateral load and that kind of thing, and everyone's going to be doing the same thing. I suspect it's the kind of thing that, in terms of, if people are thinking about what are you going to be doing battling on track with this, it's going to be neutral, because everyone's going to be doing the same thing. There's no, not that I can think of anyway. Who knows? Maybe someone's come up with something. There's nothing that you can do to make it particularly relevant. It's just changing the aero configuration corner into straight, and you wouldn't have a world where it would be beneficial to be in straight mode in a real corner. It's just not that sort of system. So relatively straightforward, and it's basically to make these cars, and it comes all the way back to that initial thing I said about the notional 50-50 split. It follows, and so much of what they've done has followed to try and achieve that, and achieve drag reductions and all sorts of other things they've done, like making the tyres a little bit narrower to make a drag contribution. And all these things are to try and get a good lap time out of the car and make it raceable and work. And all of these things, because of how difficult a challenge the regulators have set themselves. So I wouldn't get too, I mean, it's going to be interesting, but I think as a racing tool, it's going to be very, very neutral. It almost might as well not be there in terms of the influence it may. But you may have some cars that, well, you will have different configurations for different cars. So it'll add a dimension in terms of what's car's corner speed versus its sort of straight line speed. We always talk about the drag levels, etc. So it won't mean the cars are performing the same, as it were, but it's not a dynamic moment thing where you can be in one mode and someone else is in another mode and it's going to change your world, because it just isn't going to happen.
Now, it will be usable for teams to create a car that works for what they want. Let's say the Williams has always been very efficient on the straights. You could, if you have that DNA embedded in the car, you can use this system to get even more out on the straights. Maybe you get more straight bias if you want it to be. Or McLaren, we saw a lot of drag last year. They could go the other way. So it could diversify the designs, especially in the first 2 years, quite a bit. And that's going to be fun.
Nelson, the cars are also going to be smaller and lighter. You've worked a lot, obviously, in motorsports for a really long time. Are you happy to see Formula One trying to sort of slowly get back to the size of and weight of the former cars?
Well, weight is going to be very difficult as long as we have a big lump of a battery in the car, and the whole hybrid system weighs a lot. But of course, getting the car into a little bit more proper dimensions is going to help massively. But first of all, I think if you look at the renders, and we're recording this on the day that Audi made its track debut, I love the look of the car. I love the proportionality of the car. I think it looks good. And that's almost half the battle with new fans anyway. The car looks very, very very nicely proportioned, and I think it will make a difference because of the fact that last year's cars were as big as flying saucers at some point. They were just too big. It is ridiculous when you stand in front of a 2024 or 5 car and see how big they were, how big the wheels, the tires were, the wheelbase. It's just it's insane if you see how small the driver is compared to the car. And moving away from that can only help with the dynamics of driving the car, because what we need is a nimble car. What drivers are begging for is a car that changes direction, and that all starts with mass. And the mass has been too high. And if we're starting to reduce that, I think we should applaud it.
And the wheelbase reduction will have an influence on that dynamic side as well. And the other thing I will say is those numbers don't sound very good. 10 centimeters narrower, 20 centimeters shorter. But it's amazing how big a small difference can look, if you see what I mean. Because, for example, the Abu Dhabi test last year, where they had the new tyres were being tested, they're only 25 millimeters and 35 millimeters narrower front and rear. but they look significantly narrower to the naked eye. If you were just to maybe glance at it and guess, I'd probably say it was more than that. So it might surprise people how different they look. They're still going to be big. It's not going to be, a car 40 years ago or anything, but it is going to be a gain from that regard. And I suspect the biggest gain probably will be in that nimbleness that Nelson referenced, and just getting back a tiny bit of that extra sharpness. Because if you watch a car from, say, early 2000s, it's that sharpness on turning, how quickly it loads up, and you can really, really see it. And it's quite hard to sort of describe it, but I think anyone can kind of see it, because it's almost like everything just happens more instantaneously rather than lazily as it does with the current cars, or the old current cars.
Yeah, I remember, back when I raced in Formula Renault, so we were part of the undercard for a lot of the F1 events, races, and, I remember watching, like Jacques Villeneuve in the 03, 04, bar Honda, and just coming through some of the chicanes at full speed, just throwing the car around like it's nobody's business. And now you kind of see the cars sluggish, can't really move them as much. I mean, back then they looked like big go-karts, now not so much.
Okay, I'll put it like this. I think that era has ruined us.
Yes.
And that makes us cynical about what F1 has become. And we all want to hark back to that era. And Max Verstappen is exactly the same. He loves that. But I think it may have ruined us, because that was the peak dynamics that F1 ever got. It never got as dynamic as it was in that era. It may have ruined us.
Flat floors, or no, dude, you're right. I totally agree with you. It's a different type of driving now as well. So, flat floors are also making a return. I mean, gone are these ground effect floors, back as like I guess it's kind of like a 2021 style of floor. But Ed, the floorboards, I feel, could be an interesting topic of conversation early on, as this season gets started, as it does feel like there could be some interpretation with how those floorboards, especially on the front, are going to be designed. What do you think? Because I was taking a look at there was a guy on YouTube who had designed like a 2026 car, and you could kind of actually see where you could interpret something a little different within the front floorboards just behind the front axle.
Yeah, and that's going to be all about how you deal with the front wheel wake. That's really important, that interaction, because the thing with an open wheel car is the things that are a nightmare are the wheels, and they cause all manner of airflow carnage and mess and nonsense. So that interaction of that airflow that's going kind of inside the front wheels and then heading towards the front of the floor, that interaction is everything there. So that's probably where whoever's got the finest control of that is going to be in a really, really good shape. So that's going to be incredibly important. And the floors, I mean, they're still ground effect floors insofar as they're not Venturi tunnel floors, but they're still going to work in ground effect. That's still going to be important. They have got a step in them. So they're a step plane floor, really. So there'll be one step. But the other thing we'll see as well is, if you remember, pre-22, we had the kind of increasingly high rate cars for most teams, Mercedes with the exception, and later
Red Bull,
Racing Point who followed them. So you had the high rate cars. Yeah, really, that charge was led by Red Bull. And I think what we're going to see, certainly initially, is probably the ride heights at the rear being kind of midway between the ultra low cars of last year and where they were, say, at the end of 21. But there is going to be a benefit to getting rake to work. If you can get that rake up and have your floor sealed so it works well in ground effect, then that's going to be really good for performance. So when the cars start coming out, one of the things we will be looking at is there a variation in rake? And you can have a look at that static ride height and that kind of thing, as well as when they're out on track, because that can make a significant difference. So those are kind of some of the areas to look at. And inevitably, there'll be different interpretations. And the other thing everyone's trying to do is generate as much outwash as they can, because that's the thing that the FIA want people not to generate, because you push the air you don't want that's creating drag outboard, and then that just turns up all sorts of problems in the turbulent airflow that they're trying to calm down. So that's your other thing that you're trying to do. But yeah, if any CFD models of the car are really interesting in terms of what happens with that airflow hitting the front of the floor. So variations you see there will primarily, I expect, to be to do with how you are controlling and distributing all of that and calming it all down to make it work as well as possible.
Yeah, from a driver standpoint, it changes the way you'll probably have to drive the car. It'll add to the fact that everybody's been trying to keep the rear connected with the last generation of cars, and that the operating window, especially at the rear, the ride height of the car at the rear was so narrow, it was minuscule, a couple of millimeters here and there. That operating window might have opened up a little bit. But on the other hand, that means that the onus is on getting it right at the front, just like Ed says. It also means that the balance of the car shifts a little bit, the aerodynamic balance. I wonder who will like this more than others in terms of drivers, because it'll be a different driving experience for sure.
Mm-hmm. Yeah, and there's also going to be a loss of downforce too. I mean, I think it was 30% they were quoting compared to, I think it was previous regulation. Now I do expect teams that to claw that back over time. Yeah, what do you guys think the racing is going to be like with that loss of downforce?
Well, if it means that the brake distances are a little bit longer, the straight line speeds are a little higher, at least we'll have some more overlap for overtaking. We're basically balancing on narrower skates because the wheels are smaller, more narrow, but the footprint of the car is more narrow as well. I am not negative on the type of racing we're eventually going to see as soon as people get their act together in terms of drivability of the regulations. But what do you think, Ed? Are we going to see some good racing?
Well, potentially we could, because what creates good racing is variables, isn't it? In terms of, we'll talk about how much lap time advantage you need over a car in front to be able to pull off an easy overtake. We have talked about that for many years. But if you see a bigger variable in terms of how people are playing the energy management, if you're seeing drivers using their extra energy in different ways, the really, really positive best case scenario version is that you could almost create the situation where, actually, I'll let him go past me here now because I can repass him later in the lap. That's probably a little bit too optimistic, but you might see a version of that. So there are opportunities there for the racing to be good. I think the trouble is you always have this sort of spectrum of, at one end, you've got the racing is absolutely incredible and it's the best thing ever. And at the other end, you've got it's terrible. These cars are woeful. Nobody will watch. F1 will be doomed within 6 months. And the reality is never at those extremes, is it? It's going to be somewhere in the middle. And it's whether it's kind of a little bit towards the positive end or a little bit towards the negative end is the key thing. And I don't really know at the moment. I have reservations about the rule package because I think they've let that need to have the greater hybrid dictate a lot of other things. And that's limited what they can do in other areas. But it doesn't necessarily mean it's doomed. So I'm really interested to see what happens with the racing, because you will potentially see greater variables in terms of performance at any one time in a lap that could allow you to make passes and see position swapping and trade-offs that are a little bit more extreme. Because what we've generally had in Formula One is everybody qualifies in pace order. There's not much offset between qualifying pace and race pace. And everyone drives around and people say, well, why is there not overtaking? It's like, well, the fastest car's at the front and the slowest car's at the back, and they're in order in between. So why do you expect to see something? So possibly, I'm really, really interested to see not only how it starts, but how it progresses, because normally you get used to it as it progresses, the racing getting a bit worse because following gets harder and all these things, everyone gets better, it converges. That could happen, but it could also go the other way. So, yeah, it is unknown. There's a lot of possibilities, and we won't know until we've had a decent sample set of races exactly how things are going to work.
Yeah, and let's not forget that we've just had a year in 2025 where the field was as close as it'll ever be in qualifying. But we had a pretty dismal year in terms of the actual quality of racing. It dropped off midway through the season. The overtaking became virtually impossible for the top teams. So, yeah, let's not romanticize last year. Last year was great on a Saturday. Absolutely amazing. I loved it calling qualifying. The racing was not as good as we tend to think now.
I'm excited with this loss of downforce, only because when I first heard it, they're increasing the power of the power unit and the internal combustion engine and the battery together, but then also losing some of the downforce kind of reminded me of like having like a big, massive 1,000 horsepower engine with very little downforce, and usually that does tend to lead to really good racing because the driver has to be the one who makes that difference really at the end of the day, because they don't have the amount of grip that a car that has a ton of downforce on it would. It makes the driving a little bit harder as well. So I'm very excited to see how the racing plays out, because I think it could be something that goes in the right direction. Another thing that I'm actually excited to see about, and you guys may get bored on this one, but it's sustainable fuels. I'm actually really intrigued by this. And Ed, you guys over at the race, you've done a lot about on the sustainable fuels side as well, some great stuff. How these companies are going to be able to make a sustainable fuel using food waste, biomass, carbon capture.
That last one is the golden egg.
Yeah, I think so too. It's very, very fascinating. Carbon capture is something, and I've talked about it on the show before, but it is something I've followed, I would say, since 2016, because here in Canada we have a company called Carbon Engineering out in Squamish, and they were doing CO2 capturing back then, back in 2016. So it's really, to me, it's fascinating technology. But yeah, do you guys think that if they get it right, do you think it could revolutionize like the auto industry, like as we know it?
It's certainly going to drive the technology on, because this is stuff that's already happening as well. But what Formula One's quite good at is, because you're leaning so heavily on one direction of it and you're throwing so much resources at it, you learn a lot from it. So the existence of the advanced sustainable fuels is going to create just a lot of interesting scientific literature that everyone else can lean on, if nothing else. That's the kind of unseen technology transfer. Because when you think of technology transfer, you really want, take this thing off a car and put it on a road car, which doesn't really happen in such a simple term. But the knowledge, the driving of that knowledge will be very interesting. And the thing that's important about the advanced sustainable fuels, it's really interesting, but it's really, really hard because you can't see it. And even if you can see the fuel, some fuel in a jar, one fuel in a jar looks much the same as another fuel in a jar. The chemistry is the interesting bit. And unless you are a chemist, then you can only really start to get into the first principles. But the key thing is, it's not just the fuel that's sustainable. The whole supply chain has to be certified. And that's really important. And that's significant for carbon capture as well, in terms of that technology, because there's carbon capture is really interesting and there's a lot going on there, but there's problems as well, and problems of scalability and how efficient it really is, etc. And that'll drive on, and so it should do. So they've also created some limitations in terms of what you can use for it. So you can't use food stocks for it. So you can't take things that would be food and make it into your F1 fuel, and there's high biodiversity land you're not allowed to use. So it's really trying to make sure that you are making something that's genuinely sustainable and that's not taking away high value resources from other things. The downside is that makes it very expensive, because you're certifying that whole process. You're scrutinizing that whole process. You're not doing it to be as cost effective as possible. You're doing it to be as technology and performance efficient as possible. And that's why you've had all this talk about the cost of it, etc. But innovation does come at a cost. So I think it's really interesting. And you will hear talk early in the season about, such and such manufacturer or fuel supplier is struggling because the fuel supplier isn't doing the job. So if we've been talking about Honda being a little bit behind, is that going to be down to the Honda power unit? Is that going to be down to the Aramco fuel and all the other fuel suppliers as well? Who's done well? Who's done badly? And that's going to be really, really, really important and significant. It's just a shame, because it's so hard to tell that story, and it's so hard to really understand that story beyond the absolute basics. But there are mega companies involved in this, your Shells and that kind of thing, spending a huge amount of money and genuinely, they're forced to look into this technology and kind of drive its development. I'm not going to paint every fuel company as heroic in all ways, shapes and form, because it's complicated business, but there's some really interesting stuff and really, really good people working in them on this technology. So it's going to be a talking point. And you could well end up with one engine manufacturer saying, we're struggling because our fuel supply is not very good. But they might also not want to say that because they've got commercial partnerships with them. So, yeah, an interesting little subplot and a good stat. But the devil is always in the detail with these things. And there's loads of exciting technology and exciting ideas, and it could be this, it could be that, but always when you delve into it, it's that just hard work of making things work, making things efficient, making things genuinely sustainable that is really, really hard, because there's no magic bullets. Ultimately, it's not, oh, we stop using this and we use this. Everything comes at a cost because you are changing the state of things, you are consuming things. So it's really interesting, and F1 can hopefully play a part in driving that knowledge. I don't think it's going to revolutionize things necessarily. That'd be a bit of a grand term, but it's contributing. That's certainly true.
Well, at least here in Europe, and you see this also in a lot of the BRIC countries with the emerging economies, they see that electrical vehicles won't be the solution in Latin America or say India. It's not the solution, but a lot of these companies and a lot of these economies are looking now at carbon capture as at least a way to make sure that there is a fuel supply for the future. But that will be down the road. We know Aramco is doing it in 2 separate locations. We know F2 and F3 is driving on the fuel that is produced nominally from carbon capture. So that is interesting, but it is a long way away of being the saving grace for, let's say, the auto industry. But it is something they will be focusing on. But that's down the road, a long way down the road.
So with all of this, technology that we've kind of talked about, and we put it all together into a package, and the main individual who has to take all of this and execute it outside of the team is the driver. And we saw some very experienced drivers really, let's say flat out, struggle with the 2022 regulation change. Struggled with the change that was needed in the shift of the driving style. And it was funny. It was I was having this conversation with my dad the other day, and we both came into agreement on the fact that we both believe that this is a rule cycle and a driving style that I think will require some significant change, and we both believe that it would most likely be the younger drivers who will most likely adapt quicker to that change, that style that could be required with this rule cycle. And
not ruined by the previous generations of cars.
Yeah. Well, but what do you think about that? Because I do feel that the Ollie Behrmans, the Liam Lawsons, Gabriel Bortolettos, Isaac Hajar, like those guys are going to, Kimi Antonelli, adapt to this, I think, but maybe a little bit quicker than, say, the older drivers who have been in Formula One for much longer.
I think so. I think it also is logical. And look what happened. I think Sebastian Vettel is a very good measuring stick in this, and an example that through a regulation change, he lost part of what made him a lot better compared to his competition, and he struggled to regain his edge afterwards. We've seen it with Lewis Hamilton, etc., etc. The first thing that goes when you get older is your adaptability. The second thing that goes is your qualifying speed. So who is going to be adaptable enough to this regulation set? It's probably the kids that grew up behind a computer, who can think in zeros and ones, basically. And if that is... sorry, Ed, go.
No, I was just going to say, it is interesting because I do think big picture that is the case. And actually the whole thing about sim driving, I remember doing an interview with Gabriel Bortoletto earlier in the middle of last year, talking about the kind of tolerance for rear instability, because that's a quite important thing. Obviously, Verstappen's the master of that. And Bortoletto said, well, maybe those of us who are just relentlessly growing up on sim racing, we get more used to that because you kind of can brute force train yourself into it. Whereas if you do the way you may have learned to be a racing driver 30 years ago or whatever, it would be different. So that's one thing. But there are also different ways of learning for drivers. So I do agree that globally it'll be better for younger drivers than older drivers, but there's different ways of learning things. And Alonso's a pretty adaptable driver. And I wouldn't say he won't necessarily be able to adapt, but he's always been very adaptable in the way he approaches things. And there's also kind of almost 2 different ways of learning it, because some of the drivers pick stuff up really quickly and intuitively, and they almost don't know how they're doing it. For example, the change of braking style that was required for the ground effect cars, the previous rules in 22, Verstappen was on that quickly, Leclerc was. I'm not sure Leclerc had particularly thought about it. It's just he processed it so quickly. It's like the difference, Dean, if you learn how to do something just automatically and you don't necessarily know the mechanism. It's like if you try to explain to someone how you blink. Well, I don't. It's very hard, I think, for anyone to explain what the mechanism is. You just do it, don't you? That's just what happens. Whereas if you're having to learn that, you need to dig into it. And it was an interesting case with Leclerc and Sainz at Ferrari, because it took Sainz quite a while to get on top of that. But Sainz is quite an intelligent and adaptable driver, but I don't think he's the one who intuitively gets it straight away. And it's a longer process to work through. So there's different types of learning there as well. And that process has long since begun because they've been doing it in the simulator. And so it's like anything. Some things, well, we all have a few things we turn our hand to, and actually it comes quite easily. And a lot of things that come a lot harder. And some of those things that struggle with
blinking.
Exactly. I'll stay on at the end of the podcast and I'll give you a few tips. But once I've deconstructed
Thank you. I've looked at YouTube tutorials, but nothing.
But some things we try and are really hard. We can learn, can't we? And you work at it. But I imagine we've all had things we thought, right, I want to get good at this, and you try, and you just can't get that progress in it. You just can't do it. You just can't do it, no matter how willing you are and how much you try. And so there's kind of that, again, with everything, there's that three-dimensionality, and there's certain drivers who will approach things in different ways and learn things in different ways. What I am interested to see is dynamically, there was a very strong reason why there was kind of one driving style that you really need to get on top of with the previous generation of cars. A few drivers I've spoken to have said this is a little bit less having to hammer you into that, because you haven't got that problem of this high speed to low speed balance window, whereby the fundamental problem you have is if you have a strong enough front end to work in the slower corners, that often sort of pins the front end in the high speed and the rear is really unstable.
Yeah.
And that's something some drivers like, other drivers don't. And obviously the way you're driving the car has an impact on the aero center of pressure and how you move all of these things around. And it might be these new cars have a little bit more room for interpretation. It looks like it might work with a few more different driving styles in terms of pace. But then there's the question of, does it work with your energy recovery? That's the other dimension as well. So really, really interesting. Plus, when you're in a race as well with your boost button, how you use that and use it in a disciplined and clever way, that's a little bit of margin as well for you to gain in racing, because there will be some who will instinctively just go for it and not have it. Others will be better at strategizing. So there's little things like that. We'll learn more about all of these drivers.
Yeah.
And it will shift perceptions of some of them.
Yeah, that's a really interesting thing you just said there, Ed. I mean, because it does feel like these drivers are going to need to have more bandwidth to really think through a race and strategize through a race, much more than I think what we've seen over the last, 10 years, really having to think through a race and how to attack and where to pull off an attack, when to use everything. And all that stuff for me is going to be very exciting. I think we're going to have a lot of really great storylines that are going to come out of this. I was a little hesitant going into this podcast because I wasn't too sure about these regulations, but you guys sold me on it. All right. I'm sold. We're good to go. I'm excited for the season to get started.
Let's see how long that lasts.
Yeah. Don't blame us if it doesn't work. We didn't write these rules. I think it's always important to have a good sense of proportion about what we're going to see. It won't be the worst case scenario. It won't be the best case scenario. Well, let's settle. But Grand Prix racing, whatever the regs, has always been interesting. There's always been fascinating stories, and obviously people like us love trying to understand them and tell them, and fans love them, etc. So it's going to be interesting, whatever happens. And learning, I mean, think how many things at this stage before 2022 we didn't know for sure. You know, everyone knew things like porpoising and bouncing can be a problem with ground effect cars. Weren't expecting it to be so profound a problem because none of the teams were. So there could be unknowns, and we could have this same discussion in 4 weeks' time. And we're talking about a completely new set of different things. And that means it's going to be a really interesting journey, doesn't it?
Yeah. Guys, thank you so much for taking the time to do this. Really appreciate it. Ed Straw from the race, Nelson Valkenburg from VIAPlay. Thanks again, guys. Really appreciate it. And I look forward to seeing you guys in a few weeks' time at the Bahrain Well, I'm going to be at test 2. Nelson, you're not going to be there, but Ed, are you going to be
I am at
test 2?
test 1. No, I am
test
in Bahrain 1, so that's test 2. I'll be there.
Okay, so test 3. I'll be at test 3.
But I think you and I are also going to Detroit, maybe.
We are.
Yeah.
I'm a professional, so I'm going to be at both the tests are allowed to attend, not a part-timer. And I'll leave the shindigs in Chicago to you two.
We know how to live, Ed.
We try. Guys, thanks again. Appreciate it.